So welcome guys back to another video on fluid mechanics. So now this video is just the same. If you watched our last previous video, we talked about a body acted upon by pressure forces and total pressure. Now this is also one of the video we're going to be looking at. We're going to be calculating the force acting at a body in a liquid. I'm also going to be calculating the center of pressure. Now, what is the center of pressure? If you have a body, the body will be acted upon in a particular liquid at some depth. The body will be acted upon by the pressure of that liquid. So now, the point in which that pressure is acting on is what we call the center of pressure. So now, I'm going to be looking at this question, which says, an opening in a dam is covered by the use of a vertical gate. The opening is 2 meters wide and 1.2 meter high. That's a mistake. And 1.2 meter high. So on the upstream of the gate, in the liquid of specific gravity 1.45, lies up to a height of 1.5 meter above the gate, whereas on the downstream side the water is available up to a height touching the top of the gate. Find the resultant pressure acting on the gate and on the position of the center of pressure. 2. The force acting horizontally at the top of the gate, which is capable of opening it, assume the gate is hinged at the bottom. So all these we can easily express in a more simplified diagram, so you can easily understand. So now, if you can remember what a dam is, something that usually blocks the flow of water, right? So now they said this is basically the diagram we actually expected to see from this expression here. They said an opening dam is covered with the use of a vertical gate. So now an opening in a dam, now this is supposed to be the obstacle blocking this particular flow of water, and also this particular flow of water from coming here, and also this from coming here. So this is basically a dam. So now there is an opening here, and this particular gate is used to block the flow of water. So the opening in a dam is 2 meter wide and 1.2 meter high. So this is the opening in a dam. So since the gate is used to cover this particular opening, let's call it 2 meter wide and 1.2 meter high. Is that taken? Now they said on the upstream of the gate in the liquid of specific gravity 1.45 lies up to a height of 1.5 meter above the gate. So basically this is the gate, and this liquid is of specific gravity 1.45. Now the liquid lies at a height of what? 1.5 meter above the gate. So this is going to be a height. Is going to be a height of 1.5 meter. It's going to be a height of 1.5 meter above the gate. So we are basically interpreting what we are reading. So whereas on the downstream side the water is available up to a height touching the top of the gate. So you can basically see that the water available on the downstream side is touching the top of this gate. So they asked us to find the resultant force acting on the gate and the position of the center of pressure. So now the first thing we have to calculate is the resultant force. Now what's the resultant force? The resultant force acting on this gate due to the water and due to this fluid, right? So basically this water here will be exerting its own force, and this liquid too will be exerting its own force. Remember, this liquid is up to this point. Don't mind my diagram. So this liquid will be acting its own, and this water will be acting. So let's indicate the direction of my force of this liquid, this force liquid acting on the gate to be F1, and that of my water to be F2. So now let's solve. So this is basically how to express this whole thing we read on this. Now, before we go into the second question, if you can read here, they said assuming the gate is hinged at the bottom. Now, if you can remember uh if you can remember what a hinge is, if you can remember your door, there's a particular thing that holds the door but allows it to move only 180 degree axis. So it's hinged at this point, it can move. So it's just hinged at this point. It can only rotate around this point. So it hinged at this point. So now, before we go to the second question, let's solve the first question. This first question says calculate the resultant force. Now, if you can remember our previous video, we said horizontal force, or sorry, the force acting at a body or a medium in mass in liquid is equal to what? F is equal to weight density times area and times the depth, right? Now this depth of that body in mass in liquid will act from the center of gravity of that body. So we're basically talking about this gate is our medium of focus. So we're going to be considering the depth of this gate in this particular liquid. Then the other force will consider the depth of this gate in water. So the depth of the gate, starting from the center of gravity of this gate, we'll be dividing this height into two, right? So starting from the center of the gate, from here to this point will give me, since this height is 1.2 meter, this one from here, from the center of gravity to the hinged part will give me 0.6 meter, right? And the remaining distance also give me 0.6 meter, right? Now the depth, so I can basically say the depth of this gate due to this liquid of specific gravity 1.5 will be giving us, my depth will be equal to 0.6 plus what? 1.5, which will give me 0.6 plus 1.5 will give me 2.1 meters, right? Now I've got to my depth. So next is to calculate the area of my gate. To calculate the area of this gate here, which I'm using to block this down, the area, now the dimension given was what? 2 meter and 1.2 meter, 2 meter wide and 1.2 meter high. So we can basically say my area is length times breadth, which is equal to 2 times 1.2, which will give me 2 times 1.2 will give me 2.4 meter square. Is that taken? So now that's that for my area. Then next stop is our weight density. Now what's our weight density? Our weight density basically said is the weight divided by the volume. So right, our weight density is equal to my weight divided by my volume, right? Which will give me my weight, which is mg divided by v. You know that my density is mass over volume, so I can basically write it as density times g, right? So my density here, now remember I'm basically considering this first part of this fluid, which is F1. I want to calculate this F1, right? I'm considering this first part of this fluid. So to get the density of this fluid, you know that since they gave me my specific gravity, which is equal to density of the fluid, the liquid we are looking for, all over density of water, right? Now the density of water, which is what? 10 raised to power 3, right? And the specific gravity they gave me is what? 1.45. So I can basically say 1.45. I'm looking for the density of the liquid divided by 10 raised to power 3, right? So my density of the liquid, my liquid here, is equals to 1.45 times 10 raised to power 3. That's that, kilogram per meter cube. So now I've gotten my density. Going back to my weight density is equals to 1.45 times 10 raised to power 3 times 9.81. So I've gotten all my parameters. Then I can basically say my F1 is equal to what? my weight density, which is 1.45 times 10 raised to the power 3 times 9.81, right? Then my area, which I calculated as 2.4 meters square times 2.4 times my depth, which is what? 2.1 meter, right? Now, solving or simplifying this, then I should have 71691.48 Newton. So that is that for my F1. So this is the force acting on this gate due to this liquid. So now our next step is calculate the force acting on this gate due to water on this downstream. So to calculate the force acting on that gate due to my water, let's call it F2. Let's call it F2. And basically we're going to be working with the same formula, which is weight density times area times the depth, right? So now, to calculate my depth, what's my depth? The depth due to the water here, remember, the depth of the medium will come from the center of gravity, acting from the surface of the liquid to the center of the medium. So from here to here, we know that is what? 0.6, right? So basically my depth from this liquid surface to the center of the body is what? 0.6 meter. So I can basically say my bar x is equal to 0.6 meter. Is that taken? So next up is my area. Since we have successfully calculated the area of the body of this gate here to be 2.4 meters square, I can just rewrite it as my area here is equal to 2.4 meters square. Now, my next step is my weight density. You know that my weight density is equal to what? Density times acceleration due to gravity, right? And now, since the medium we are working with here, the liquid we are working with here is water, right? If you can read from the question, they said the downstream side, the water is available up to. So we are considering the medium here to be water. So the density of water here, we know that is what? 10 raised to the power 3 or 1000 times 9.81. So I can basically calculate my F2 to be what? F2 is equal to my weight density, which is 10 raised to the power 3 times 9.81 times my area, which is what? 2.4 times my depth, which is what? 0.6. Is that taken? So now this I can successfully say is equal to 14,126.4 Newton. So this is the force acting on the gate due to water. So this is the force acting on the gate due to water, 14126.4. So now remember our question says calculate the resultant force acting on the gate. So the resultant force, remember this force is acting on this gate and this one is also acting on this gate. Now which one do you think will be greater? Now if you remember hydrostatic law states that the pressure will basically increase due to the depth of the liquid. Now, due to this the depth of the gate from this liquid here, the pressure or the force acting on this gate will be higher than the pressure acting on this gate due to water. Now, let me repeat myself. I said hydrostatic law states that pressure increases with depth, right? If you can remember this law, this formula, it says pressure is equal to density times G times the depth, right? So this is hydrostatic law, which is density times gravity times the height or the depth of the medium in the liquid. So pressure increases with depth. So considering the other side of this dam, the pressure of this gate will increase due to the depth. You can read the depth, you can look at the depth of this liquid. It's a lot higher than the depth of the gate in water. So the pressure at this point will be higher than the pressure at this point. So I can basically calculate my resultant force to be my F1, which is given to me as 71691.48, and my F2, which is given to me as 11412.4. So my resultant force will be equal to, let's call it Fn, will be equal to F1 minus F2, which is 71691.48 minus 14126.4. So my Fn is equal to what? My Fn is equal to 57565.1 Newton. So that is that for the first term. Now they said we should calculate the center of pressure. Now from our question 1, they said find the resultant force acting on the gate and the position of the center of pressure. So basically, the position of our center of pressure is the point in which our pressure is acting, right? That's what I defined it earlier on before the starting of the video. I said the center of pressure is the point in which the pressure in that liquid is acting, or the point of action of the pressure. So the position of my center of pressure, if you can remember, the formula for finding center of pressure is equal to, call it H bar is equal to moment of inertia from about center of gravity divided by the area times the depth plus the depth. Now, this is the formula for finding center of pressure of a vertically immersed surface in a liquid. Now, what's a vertically immersed surface? So a surface that is just dropped in a liquid, just like this pen. If I just drop this pen in a bowl of water, this is vertically immersed. But if I put it like this inside a bowl of water, this is horizontally immersed. So pressure acting at the point horizontally immersed in a liquid is just basically there is no center of pressure for horizontally immersed surface in a liquid. Why? Because the center of pressure is the same thing as the center of gravity of that body. So, but a vertically inclined surface which is dropped in a liquid will have a different center of gravity and a different center of pressure. What am I trying to say is that, for example, I drop this horizontal bar in a liquid, this vertical bar in a liquid. This is the center of gravity. Now, since it's a vertical surface, it will have the center of gravity, which is G, and it will have a separate center of pressure. The pressure will be acting at a different point from the center of gravity. But if it's a horizontally immersed surface in a liquid, the center of pressure will be equal to the center of gravity. So that is why we're having a different center of pressure from its center of gravity. So we call the center of pressure C. So the position of C to the surface of the liquid, the position of C, of this C here, to the surface of the liquid is what we call H bar. I'm going to repeat myself. I said, this is the formula for finding the position of center of pressure of a vertically immersed surface. Now, what am I trying to say? Consider this bar here. Now we have the center of gravity and we have the center of pressure. This is the point in which the pressure of this liquid is acting on this bar. So the position of center of pressure to the surface of the liquid is what we call H bar. And H bar is equal to the moment of inertia about center of gravity divided by area times the depth plus the depth. And that is that. So we're going to be calculating the center of pressure acting on that gate. Now, we're going to be considering the center of pressure due to the first liquid and the center of pressure due to the second liquid Is that understood? So we're going to be considering the center of pressure due to the first liquid and center of pressure due to the second liquid. So to calculate the center of pressure due to the first liquid, let's calculate that. We call it H1. Center of pressure due to this first liquid here, let's call it H1 equals to Ig over A bar plus X bar. So my Ig, which is the moment of inertia about center of gravity. Now, moment of inertia of a rectangular gate or a rectangular body is equal to BD3 divided by 12. Now, this is the breadth or the width, then this is the depth divided by 12. Sorry, 12. So now, the depth of my gate here, which is here, the depth of my gate here, which is what, 1.2, and the width, which is 2 meters. So I can basically calculate this as 2 times 1.2 raised to power 3 divided by 12, right? So this will give me 0.288. That is my moment of inertia about center of gravity. Then the area of my gate, which I previously calculated as 2.4, I can just write it as 2.4 meters square. Then my depth, which is X bar, from, remember we are considering this the first side of this liquid. So my depth, if you calculate it as 2.1, you can write it here as 2.1. So my H bar 1 is equal to my moment of inertia, which is 0.28, right? 0.28. Putting it in this formula, I have 0.288 divided by my area, which is what, 2.4, times my depth, which is what, 2.1, plus my depth, which is what, 2.1. So calculating this, I'll have my H bar 1 to be 2.157. Is that again? So now this is the center of pressure from this gate to the surface of this liquid. Remember, we considered the first side of this liquid. So this is the center of pressure from this gate to the surface of this liquid. Now, let's consider the center of pressure acting on this gate due to water to the surface of water on the shorter side of the stream. So let's call it H bar 2. H bar 2, which is equal to moment of inertia about center of gravity divided by area X bar plus X bar. Is that taken? So now let's call it H bar 2. And let's call the depth here to be X bar 2, X bar 2. Now, this we're considering the position of center of pressure from the surface of water on the shorter side of the stream. So the same thing goes for my moment of inertia about center of gravity will be equal to what? 0.88. And the area of my gate, remember we calculated as 2.4 meters square, and my depth from the surface of the liquid to the center of the gate, which we calculated as 0.6 meter. So we have my depth X bar 2 equals 0.6 meter. So putting it in my equation, I have a center of gravity with 0.288 divided by my area, which is what, 2.4 times 0.6 plus 0.6. So this gives me, putting it back in my equation, I have 0.8 meter. So this is by my H bar. Successfully calculated my center of pressure acting on both sides of the liquid. Now we are asked to find the force acting horizontally at the top of the gate, which is capable of opening it, of course. Now, the force that will act horizontally at the top of the gate will actually coincide with the force that will act at the top of this liquid here, at the top of water. Again, so the force acting at this top of the gate will actually coincide with the force acting at the top of the liquid here. So let's call it F star. So that's the horizontal force we're looking, which is acting at the top of the gate, will actually coincide with the force acting at the surface of the fluid. So now to get my horizontal force, since I have my F1 and I have F2, now basically to calculate this, it will be easier for us to take moments at this hinged part, because this is the most common part with respect to the other side of this fluid and respect to the other side of this fluid. So these are what actually they have in common. So it will be easier for us to take moments. So taking moment at this hinged part, we'll be considering the distance from this force on this other side to the hinged part, the distance from this force on this other side to the hinged part, and the distance from this horizontal force to the hinged part. So if you can remember, the formula for moment is force times perpendicular distance. So taking moment of F1, right? Since this F star and F2, they are on the same side, so we're going to be having some change in signs. So taking this F1 to this hinged part, that's the horizontal distance of F1 to this hinged part. Since my force is acting, remember we calculated the center of pressure, that's the center in which your pressure is acting. So the point in which this my force is acting is with respect to this, to the surface of this liquid, is what we calculated as my center of pressure, which is what, H1. I'm going to repeat myself. I said, remember, we need to make use of our vertical distance to calculate our moment. We need to make use of the vertical distance from here to this hinged part, right? Now, I said the distance, the point in which this force is acting, is my center of pressure. Like I said, the point in which your pressure is acting is your center of pressure. So the point in which this particular force is acting is my center of pressure. So my center of pressure with respect to this horizontal surface is what we calculated as 2.14157. So remember, I'm looking for the distance of here to here. So if from here to this point is, remember, from here to here is 1.2 and from here to here is 1.5. So 1.2, if from here to here is 1.2 plus 1.5, then minusing it from the center of pressure of this force, is the point in which this force is acting to the surface of the liquid, I should have my distance over here. Now I'm going to repeat myself. I said from this point, remember, from this point up to the hinged part, remember, from here to here, we said is the height of the gauge, which is 1.2, right? And we know that from here to here, which is the height of this liquid, is what, 1.5. 1.5, right? Let's call this 1.2. So from here to here is basically 1.5 plus 1.2. Now, since I have calculated my center of pressure with the center of in which this force is acting to the surface of this liquid, I calculated it as what? 2.157, right? So this, my H1 here, my H1 bar is 2.157. So basically, this distance minus the distance to the surface of the liquid, I should have the remaining distance to my hinged part. Then I can take my moment. So basically, let's calculate what we're actually talking about. So I'm basically saying, so from here, from this point to the hinged part, the height is given as what? 1.5 plus 1.7, 1.2, which will give me 2.7 meters, right? So from here to here gives me 2.7 meters. So From here to the surface, the point of application of my pressure to the surface of the liquid is what we calculated as my h bar 1, which is equal to 2.157. That's the position of center of pressure, that is to the surface of this liquid. So given this and given this, I can calculate the distance from F1 to the hinged part will be equal to 2.7 minus 2.157, which will give me 0.543. If you give me 0.543 meters to the hinged part. Now you're going to see why I'm actually calculating the distance of F to the hinged part, because I want to take moment at that hinged part, because the hinged part is what the force at the other side of the liquid and the force on the other side of the liquid have in common. So then I can calculate my horizontal force. So this is the 0.3 meter to the hinged part. So we do the same for the other side of this, of my liquid, of my F2, which is the side of my force. Now the distance, the point of application of my F2, we calculated it as my H bar 2, which is my center of pressure, which is 0.8 meter. Now don't get me wrong, my depth acts at the center of my body, but my force doesn't act at my center of gravity. Like I said, your pressure, the point of application of your pressure or your force is your center of pressure. And we calculated the position of center of pressure as H bar 2 and H bar 1. So the point of application of my force, which is my H bar 2, we calculated it as 0.8, right? So basically, the point of application of my F2 to the surface of my liquid is what? 0.8, right? That's my H bar 2, which is 0.8. So the remaining distance to my hinge part, I can basically say, since from here to here is 1.2, so then I can say 1.2 minus my 0.8 here will give me my remaining distance. So then I can say 1.2 minus 0.8 give me 0.4 meters to the hinged part. Now then, let's call it H1 and let's call it H2. Remember, we use bar for the other one. Now we remove the bar, so let's call it H1 and H2. Then I can successfully take my moment. So taking moment at this hinged part, I can say F1 times the resultant distance to this hinged part, F2 times the horizontal distance to this hinged part, and my horizontal force to this hinged part. So taking moment, taking moment at the hinged part, I can say F1 times the perpendicular distance from F to this hinged part, we got it as what? 0.4543, right? So F1 times 0.543. Now, since this one is coming opposite in direction to the F1, so there's going to be change in signs, then I can say F2 times the horizontal distance to this hinge part. Now, since it's coming opposite direction, I call it minus F2, which is what? F2 times the perpendicular distance to the hinge part which we got it as 0.4 minus another change in sign because it is actually in the same direction with my F2, my horizontal force, which is F star that we're looking for, times the vertical distance or the perpendicular distance, which is this to this, which is what? 1.2, as F star times 1.2. Now, since for balance or equilibrium, it will be equal to what? 0, right? Then taking this one to the other side, then I have F1 times 0.543 equals F2 times 0.4 plus F star times 1.2. Now we know that my F1 is what? 7169. That's 71691.48 times 0.5 1.43 is equal to, you know that my F2 is equal to what? My F2, we calculated it as 14126.4. So my F2 is what? 14126.4 times 0.4 plus my F star times 1.2. So basically we're going to be looking at collecting like terms. So taking this one to this other side, this is 71691.48 times 0.543 minus 14126.4 times 0.4 equals F star times 1.2. Now you can just rearrange this to be equal to F star times 1.2, this minus this, taking this to this other side, bringing this other side, just rearranging it to give us a more finishing term. We have 71691.48 times 0.543 minus 14126.4 times 0.4. Dividing both sides by 1.2, dividing both sides by 1.2. Then my horizontal force, which is F star, will give me 27725.5 Newton. To kilonewton, we have 27.725 kilonewton. So that is that for my horizontal force F star acting at the surface of the gauge, which is we're capable of opening it. So thank you guys for watching. Please and please subscribe.